Hello everyone. Today I'll be teaching you all periodic classification of elements, that is chapter 5 chemistry. Here at present we know 118 elements are known to us. In that 98 are naturally occurring and the rest are synthetic, that is man-made. So to arrange all these elements, now presently we can see here, this is the classification of modern periodic table where systematically all the metals, non-metals have been arranged. Here you can see these are arranged in the groups, that is 18 groups and 7 periods. So to come up to this point, there were many people who proposed their theory of classification which did not gain importance because they had limitations. So we'll see which are those. Here Lavoisier, first he classified all the elements known during his time as metal and non-metal. Then he did not classify further, he just told that all elements can be classified as metals and non-metals. Then next person was Dobereiner and he gave the classification and named it as triad. Then during his time there were 33 elements known. Next person was Newland. Newland gave his classification and he told his classification Newland law of octaves. Then we'll be studying all here. During his time 54 elements were known. Then next was Mendeleev's periodic table. Mendeleev is known as father of classification, though his periodic table was not accepted because it also had certain limitations. Now presently what we study just now I showed you is modern periodic table. So in this chapter we will be studying about Dobereiner triad, Newland octave and then Mendeleev periodic table along with modern periodic table, its classification, its trends, everything. So to start up with Dobereiner triads, here during his time 33 elements were known. Now we'll see how did he classify. He classified here, he was a German chemist and in 1817 he proposed his classification. Dobereiner arranged, if at all we take 3 elements, say A, B and C, he told that atomic mass of the middle element is equal to atomic mass of the average of atomic mass of A and C here. So we need to note here that he arranged certain elements with similar properties, that is both physical and chemical, in groups of 3 called as triads. The elements were arranged in order of increasing atomic masses. You note that it is increasing atomic masses. And the atomic mass of the middle element was almost the mean or the average of the atomic mass of the first and the third element. This is how, if at all we take any 3 elements, arrange them in increasing order and of atomic masses, then atomic mass of the middle element should be average of the first and the third element. Dobereiner suggested or gave 3 triads during his classification. We will be studying all the 3 triads. Example, first triad is lithium, sodium and potassium. They are called as alkali metals. If we arrange them according to increasing order of atomic masses, you can see the middle element, that is sodium. Atomic mass of sodium is average of the atomic mass of the lithium and potassium. So when we add up this and divide by 2, we get 22.95, which is approximately equal to the mass of sodium. When we arrange of similar chemical property or physical property, we will see what are the common properties of all these 3 elements. Common properties are, all the elements are metals. We can make out lithium, sodium, potassium are metals. All of them react with water to form soluble hydroxide known as alkalis and evolve hydrogen gas. That is lithium hydroxide, sodium hydroxide or potassium hydroxide is formed when they react with water. All of them are monovalent. Their valency, sodium you can make out, when we arrange sodium atomic number is 11. If we arrange them it is 2, 8 and 1. So valence, monovalent, valency is 1, which means they exhibit valency of 1 in their compound. So all are these similar properties of the first triad. Now if we move on with the second one, second triad, that is calcium, strontium and barium. Again, these are called as alkaline earth metals. Here, calcium, strontium and barium. Atomic mass of strontium, that is middle one, is equal to the average of calcium and barium, that is 88.7, 87.6. Though it is not mathematically equal, he also told that it is almost or approximately equal. So chemical properties here, similar properties of calcium, strontium and barium. All three elements are metals. All of them show valency of 2 in their compound. Valency, if we take atomic mass of calcium, that is 20, arrange electronic configuration 2882, so valency here is 2. All of them impart characteristic colors to their flame. All of them impart characteristic colors to the flame means when these elements are heated, they impart particular color. For example, barium, when heated, it impart pale or apple green color when heated. Likewise, strontium gives red color and calcium gives orange red color. Moving on to the third set, that is triad, chlorine, bromine and iodine. All are non-metals and they are called as halogen. Again the same thing, when they are arranged according increasing order of atomic masses, that is chlorine, bromine and the middle one is bromine. Take out atomic mass of bromine, will be the average of chlorine and iodine, add that thing. Now here you can note down bromine is 79.9, whereas average we are getting 81.2. So we cannot predict, not even approximately equal. So according to Dobereiner, he predicts that, he tells that here it is almost equal to the middle one. Here only we can see the limitations, that they are not exactly equal, not even approximate. Fine. Common characteristics. All the elements are non-metals. We can make out non-metals. All the elements are diatomic. You know very well what is diatomic. Chlorine, bromine and 2, they exist as Cl2, Br2 or I2, all the halogens. All of them show valency of 1 in their compound. If we take chlorine 17, atomic number 17, then it is 287, number of valence electrons are 7, valency is 1, so it is valency is 1. All of them are highly reactive chemically. Then why we do not study this one at present? We are studying modern periodic table, since this has limitations and he could not arrange all the elements known at that time into triads. We know 33 elements were known during his time. When you look out here, hardly he could give only 3 set of triads. He could identify few triads. The same thing. As a result, Dobereiner triad could not gain importance. So this is the limitation of Dobereiner. For 2 marks they might ask you the limitation, or they even might ask you to explain the Dobereiner classification or triad with an example. I would suggest you better give the third set or first set as your example here, or anyone, the question might be asked in any order. See to that you prepare well. Okay, next video I will be making about Newland's octave. Thank you.